Okay, I have 12 attendees at the moment, so welcome to our class in ITDB 101. Okay, and of course, this would be our, I think, third meeting now this time. Prior to our first meeting, we just had our, what do you call this one, orientation, class orientation, particularly on the delivery plan. And And last Tuesday, I believe that we have started officially our chapter one. Okay, for those who are unable to attend the class, I have already uploaded the link for our recorded sessions, even from day one. That will also include this one later on. Okay, so hopefully others will still be joining in. Abdul Salam, how are you, Abdullah? Masood and Turki, Basel, Mariam, Masin, Osama,
Yes.
Ryan, how are you, Abdullah? Tuful, Badar,
How
and
are you?
Tuful. I'm good. Wafa and Sainab. Hopefully, I'm seeing you guys though. But anyhow, if you are having some, what do you call this one, on campus, try to say hello in my office, right? So and tell yourself that I'm in your class. Hi, Sainab. Thank you. Right. So pretty much it's end of the week, and of course, still we have to complete our outcomes. And this time, of course, we will just continue what we had not completed at the moment from particularly in chapter one, and it's all about overview of the database. So bear with me, guys, with me this time because chapter one is a bit um, more basically pretty much more on theory, and so much foundation and terminologies you're going to learn on that one. But at the end of the day, of course, you're be getting to know what is database means, though. Particularly when we jump now to chapter two, that the practical side of this subject will going to start. Not necessarily we have to be in the computer doing some programs, not at the moment. All the practical side of designing of a database will be definitely start with chapter 2. Okay, so without further ado, we don't have any clarification. I want you to, I want my class to be interactive though, in case you find maybe some doubts while I'm doing my lesson. You can raise your hand or you can open up your mic and you can ask question, no issue, right? This is my job, so that we could be in right track though, especially if we're doing now some a bit confusing lessons or topics that needs more on practice. I will be with you guys. Don't worry. Anyhow, I want my students will be of course passing this course or the subject and getting a good marks, inshallah. All right. So without further ado, allow me to to share my desktop. Okay. Allow me to share my desktop. And since you have only 24 students, maybe I will mark your attendance later a bit. Okay. And okay, 1 second. I want to try something else though. Let me see. Um, Windows. Okay. Okay. Let me try to do some sharing at the moment now. Screen sharing or Windows. There are no other options over here. Um, I think so. There are no other options though. Yeah. Okay. Now this time you're seeing my desktop. I believe so, right? And of course, you will find our delivery plan once again for those who haven't had course delivery plan. This would be a good for you as a guide throughout our discussion. And of course, number one is of course this course handouts. So it's better for you to have a soft copy at the moment with you, so that in case you want to read our past lesson, you can also give some more details of information other than the the PowerPoint that I'm using at the moment, right? And you can see on the online class links, you will find now a couple of URLs there. So from day one that we started our class orientation, and last, I think Tuesday, no? That partially we have had our overview of database. Okay? And okay, so this time let me just open up my my PowerPoint, and let me see where exactly we have completed though. But anyhow, don't worry, I'll give you some recap what we have discussed last meeting. Anyhow, that is only an hour class. All right. I believe we started working now with some few terms: database, uh, TBMS, data processing, and particularly in the components of database system, which is data processing and information. So we have discussed this one last meeting, and we also compare what is data and versus information. So each one of these is very important because they are pretty much correlated. It won't have your information be there if we don't have data. So at least now you know that your data is just barely a raw facts and figures, that it might not be meaningful unless it would be processed. That only will become an information. And if you ask me, teacher, what is examples of process, just like here in the diagram, right? This is just for a review, okay? This is a recap for last meeting. What are the things happening or going on in the middle between your data and information? What is this processing? So processing can be process like they're being interpreted, or it might be organized, or they might apply some formula, or they used to apply some statistical analysis, and eventually it become more structured, and it would be presented in such a way it would be meaningful for human understanding. Yeah, because sometimes data is just barely raw. We don't even know what is that data description otherwise if we already process it. So this is what normally people who are working with some surveys, questionnaires, interviews, and if they want to analyze it, so first they have to gather those data. By how? By means of questionnaires, or by means of interview, right? Or answering some questions, and then later on you will take the respective answers. And you will apply some analysis over there, or some statistical formula pretty much. That's why processing takes over on that middle of the process of your data and information. Now, by the time you complete that process, that will be now become more meaningful, useful information. So that's why data versus information is very important for our database. Eventually, we will we will see this database management system. We also discuss the traditional file system concept. The reason why we have this first before the database, because at least we haven't even born yet how people are doing file keeping, something like that. How they what's the concept, maybe 20 years back, or I don't know, maybe 15 years back, or without the advent of computer yet, and even the computer is already there, how they do the traditional file system concept if database wasn't even there yet. At least we saw that one. We learned that the file system is basically there's a problem. It's only pretty much limited. The difference between this application in each one of department, they have independent program. Imagine that one, but independent, or I mean, they're all dependent on that program, because that one is the information might be needed only in this. But the problem is their information is shared upon different location. So the problem was that data integrity will be there because if someone already update that information from the other location, what about the other application or other department? They have to rewrite the program again. They have to make some changes so that it will be the same from the others. Similarly, from the other application program. So this one is a bit tedious. Imagine you don't know which one is doing the updates. You don't even know which is now the latest information. That's why we have seen different departments in diagrams. That most likely these departments might be needing some information from other department, from other department, from other department. And the worst is you can control them because they have all your documents or they have all your information. If someone will going to update that one, they have to update. What if they don't update from the other department? And that will now clash. So there will be some discrepancy. That's why the integrity of your file, of your data, will be totally having some problem. So duplication of common files which have been shared on different department are there, and that will lead you to redundancy. Redundancy came from the word redundant, right? Redundant means you have done it this one, you have to do it again and again and again. So this is how basically the traditional file system before. For your clear example, just like I have shown you last meeting, like how the file-based college system used to be before in the traditional file system. See, student file is normally coming from Students Affairs Department, advisor files. What are these students? Of course, they have to study in each one of the departments, and that will needed by the lecturer. And those lecturer are also teachers, right? Those are particularly staff. That those information of those respective lecturer might be handling by other department, particularly in HR department. So imagine during those days, the file-based system, they need to have separate program. Program A, program B, program C. This is what I'm saying before, right? So what if we have a centralized database and all of this shared information, once that you updated it, it will be updated throughout all those departments, right? But unfortunately, the file traditional way before, it wasn't like that. There's so many limitations. That's why they are having some redundancy, duplication of work, and the integrity of your data wasn't there. So that's the big problem during those days. And the worst is they might lose your information if maybe someone deleted it, and you never know where is your exact latest information anyhow. So in that way also, because of that, we could not control those people who are manipulating your information because they are independent to other programs, right? And the thing is, it will take more time to work on that. And this is what we wanted to eliminate. Not 100% to eliminate, but at least we reduce this kind of problem. Just like we reduce this kind of duplication, totally we optimize your file-based system in such a way. We have a very good stable integrity data that you will say that exactly this is the latest information you had because you have full control of your information, right? Full control, I mean to say full control, not everyone can delete, not everyone can update. There will only be a certain user could only possibly do that one, and they could be audited as well because we will going to know whoever the last person updated, whoever the last person or the first person who created that account, who inserted a new information from the database, pretty much like that, right? So, but then, of course, file-based system was limited during those days. And these are the things that I have shown you. One, data redundancy. Two, program data dependency. Three, data integrity problem. And four, concurrent access anomalies. So we have seen this one last meeting, right? So these are the things that I have given even previous lessons also as well. And we touched some current technology and trends. Let me just skip this one already. And by the time that we have seen the traditional, before we jump into the latest technology that we're currently having, we should know first how the database approach. So we now understand what is the database. It's a shared collection of related data. Shared collection. So not only one, which means there are so many databases that might be shared throughout your location pretty much like they are all might be related. Your student ID and student name might be related. Your student ID or college ID will be related to your course marks, pretty much maybe like that, right? And many things. So that's why we have now this DBMS. That DBMS stands for Database Management System. If a database is a collection of shared related data, a DBMS is a software that collection of all different programs within a certain database, which is stored all your data there. So later, we come to know that this DBMS system can be an Oracle server, or maybe it could be MS SQL, Microsoft SQL Server, or SQL Server, or MySQL as well, which is also running on that particular server, right? So we have so many different versions of DBMS, right? But bottom line is they have the same functionality, though they have small differences on the way how they approach the writing of syntax, but still at the end of the day, it's still the same. You're doing a query, you're updating it, you're doing some data manipulations, you insert, you delete, right? You can make some querying, something like that. So all of these data approach, definitely all your data is basically stored in a certain table, which this is what we will learn maybe before midterm. One of the chapter that we will now see the transformation of these into a typical table. Those tables are now most likely inside your DBMS or within your database. That definitely stored all your information. But take note, this stored table might be also be shared upon to another table, which what we call a relationship. That's why from the definition of database, it's a shared collection of related data. So same also in table, they might be having also some related table within that table. Not only one, could be more than one, so many. Right, so we have already touched this one. But it seems that now, I might be jumping now over here. This diagram is what I'm pertaining to the database approach. It's just like you have, remember I said, why we should have a centralized one though? Not like the traditional file base. They have separate programs. And each one of these departments are pretty much dependent on that program. And the worst is they have to rewrite that program again and again every time you change your shared information, right? So now in the database approach is pretty much we have eliminated that one. So because you can see from the diagram, suppose we are one of these users and we are all using the DBMS or database management system. Even though we are opening or running a different application or program, application itself within the DBMS. Application 1, maybe that belongs to registration department, students affairs. Application 2, maybe a program belongs to engineering department. Application 3, maybe coming from a foundation department, and so, right? But you can see from the diagram, it's pretty much centralized because this DBMS is what? It's now not only shared collection of data, but it's combined with different programs that are running within your database. So it's quite much more better compared to a traditional file-based system. Even traditional file-based system was a program, even they have already a computer system during those days. But but still, it's so many limitations, right? We still have many limitations. So that's why maybe one of these users will be administrator of database. Maybe one of these users would be a supervisor, or maybe one of these user is just the clients that they can only view their own transactions and they can just create a transaction, something like that. It depends what kind of application they are running through within the DBMS. Okay, so it's very straightforward that we will see later those limitations and disadvantages that I have shown you. Pretty much all of these one will be going to be much more better when it comes to database approach, right? So we see continuation for that diagram. Several departments now are all connecting within a centralized DBMS. Why? Because those departments might be needing some information from other departments, right? So, which means you can see that cylindrical diagram there. They are all shared database within the employee. Think of a database that there's one database running in one department, like in students affairs, one database running in IT, one database running in business department, one database in foundation engineering, one database in finance, one database for housing and student assistance, something like that. But they are all centralized in one DBMS because they are all collection of different programs that run through within that one, right? So if if the students affairs update your credentials over there or maybe your information, if we pull out your information from the IT department, we can see your latest information will be there. You suppose you are coming from the foundation, of course they will update your information. They put your information from the database, and then by that time that you join in the foundation, eventually you have completed. That's your status is studying on the foundation. But if you shifted now to some specialized department already, they they will going to update your what do you call this your status or your probably your level of study right now that you are now belongs to maybe in software development in diploma 1 or diploma 2 IT department, something like that. So we will see throughout all the departments that your current status is like that, right? So which means this is much more better compared to the traditional file-based system that we have seen though, right? So no duplication of file, your redundancy of doing many tasks for different users or different departments will definitely be eliminated. You might be controlling also those concurrent access controls that they have only limited, what do you call this one, privilege only to update your system. Whoever only those people assigned to do so, they can do that one. Not everyone just can do it, but they definitely they will be audited as well because it will be recorded the moment they updated your information. And the most important is the integrity of the data. Right? This is the most important. The integrity of the data is definitely we will hold the latest, and there will be no doubt that that information is not updated. It's the latest one, right? Right. So which means we're seeing all of these this time, and of course there will be advantages of database approach compared to the file-based system, which we have listed those disadvantages. And what are those? It's only basically the answer of those limitations, the answer of disadvantage of the file-based system. See, reduce redundancy. I'm not saying 100% we totally remove the redundancy, but at least it is about saying that in layman terms, at least we minimize it. Right? There will be no duplications of tasks to do. And because since we are now using the database approach, much more better if we totally remove the data redundancy, right? Only, why they say it's only reduced? Maybe it depends how you design your database. If you haven't optimized fully your database and the process flow, probably there's something wrong with your system analysis and design. They might be having still redundancy, but at least not totally like the file-based system. The program data dependency, because it was already been centralized, right? And then the most important is what I'm saying about integrity. We forced now your data by giving constraint on it. We will study this part of the term constraint, integrity at later part of some chapters so that you will fully understand what is the meaning of integrity constraints, right? Integrity constraints, anyone, I will ask students IT who completed ITDB 101, they should know what is integrity constraint, right? Because this is our foundation of learning our database, pretty much fundamentals of database. And see, the concurrent access will gonna be monitored, and there will be a set of people who are only being given a privilege to do some tasks, right? And the thing is, every time they do some updates, who are those people or users accessing the system, right, or the database, will be also be recorded, will be also be recorded, like a teller that you're paying a credit card and you're on queue. Once that you pay your bill of credit card, not online, maybe you're on queue, who will be that teller sitting in front of you there, who will be accepting your money. It will your payment will be recorded within the same day, but the important who did the transaction of or assisting that particular customer, because he or she logged in as a teller there. So every access will be controlled as well. So this is what pretty much advantage of database approach. And I think I have mentioned so many uh, times the users, right? And this is now knowing who are the database users. I believe every one of us are database user. I myself, you yourself, your parents, your friends, your colleagues, right? They are all database users. Only we have used them in different terminologies, right? And most likely, most of us are definitely end users. End users are people who are using the system, even like you just log into your personal social media account, your Instagram. You are already an end user doing some TikTok. You should have an account to do that. You are end user. Creating an email, sending an email to your colleague or friends. You are end users. Checking out your bank account online. You are a user, end user. Purchasing online through an e-commerce website, through Talabat. You are end users. Each one of us are end users though. Even though you're just watching a YouTube movie though, you're still an end users. Because why? Because each one of us are using a system, and most likely what we're dealing is we're getting information out of the database that we might be using in different kind of portals, right? So end users is everyone, right? So everyone. As a student, creating your timetable, registering your timetable. Of course, you have to log in from the CIMS ministry website or portal. You definitely your end users. There are different levels of database users because some users, some users of database, they can be in high level or in the mid level kind of, or maybe on the highest level. That's why we have this database designer and application programmer. I might say these are people who are developers already. The database designer is most likely what we are now learning here in ITDB 101. All the things that we will learn will be under the database designer, right? I'm not saying it's pretty shallow. That is the foundation. Because even my BTech courses who are specialized in database, they still going back to ITDB 101. What they have learned there, they have to apply in BTech. They have to apply there in BTech, right? Because every things that they have learned there is pretty much the foundation of this IT of database. Some of the users might be application programmers. You might be confused, teacher. Um, what is the difference of application programmers from a database designers? A database designer is you are the one creating or prototyping or making a plan before you physically create the database, right? This is, I'm not saying that you're not a programmer as well. They have some codes as well in ITDB 202, just like I said during the orientation, right? We have these SQL statements for you to create after designing your database, because you have to implement your plan in your blueprint once that you have already analyzed it, and you have to put that one in blueprint. And the thing is, as a database designer, now you will sit in the computer and create that database itself. Now, what about the application programmers? Oh, by the way, database designer is most likely working on the back end. Okay, you might be hearing about what is the back end. I will tell you what is this, because most of the course project students taking IT, IS, database, software development, first thing I will ask, what is your back end and what is your front end in creating your course project? Or pretty much on database designing, you're doing now the back end. You're preparing the back end because this is your database. Planning will be there, and of course, designing transformation into a real database table and relational database table will be there. So this is what we will study each one of the chapters. And what about teacher, the application programmers? Application programmers are pretty much they are people who are developing the front end where exactly the end users are using it. Understand? Some people who are developing in Java, people are developing in Android applications, people are developing probably in iOS or a different platform, across different platform. People are developing a Windows-based application. People are working with developing an application that will work as a web application throughout all cross-platform, cross devices, smartphone, computers, and it will become more responsive because it will just depends on the size of your screen. They are developing those interface, and most likely they are running a typical program or software or language specifically, like Python, or maybe some of which are still doing the C++, right? Java, even writing an HTML is still a part of application programmers, PHP. They might be writing another sophisticated programs as well, and so many things. So these are basically, I might say, maybe these are the software engineers, most likely, because they are working on this. But what is the help of this database designer? The moment that application programmers, they need also to use the database because they are also database user. They have to connect the programs that they have developed into a database which had been designed by a database designer. See? So even though that they are software developers, software engineers, they are still a part of a database users because they have to link, they have to connect those programs that they have developed. Even they have done it in different platforms. And of course, I think the most highest, pretty much highest level of the database is what we say it's a DBA, database administrator. Now, totally this database administrator is, of course, he's handling all the application. Application had been developed by application programmers, even they are running in different platform. They're definitely handling so many people who are developing and designing the database, and they are the one deciding all the instances of the database, gives them access, concurrent access for each one of the application. They define the schema. The term schema here is just for a new term, pretty much for you though. We will also learn that word schema is like your database itself. He is also responsible for communicating with the different end users, right? And the number one is the database administrator is the one responsible for keeping your data secured, defining the security, and providing a backup and recovery in case there will be some problem on the server, or maybe there will be some hackers might uh, trying to sniff on your information on your database server, but they will do the rest. This is their own responsibility, right? So, which means now you're seeing pretty much all of those different users. We might be having some review questions before ending up this chapter. I'll be giving you 10 questions and try to answer this one by, of course, reading our book, and these questions will be shared upon in our e-learning, right? It's quite common that you might be seeing direct answers as well in our book, but I want you to ready yourself because they might be having some, what do you call this one, like some questions that might be practical by just gaining what is the difference between a data and an information. You can also answer it the way how you understood it, not just like by copy pasting the information from the book or from the internet that you Googled it. The most important is you can answer this one straightforward. You can see the questions. Where do you encounter the use of database in out everyday activities? Right? I always say, what are the things that you're within your environment, how you encounter database? So I have given so many, right? Or maybe you want to replay our recorded session, what this Mr. Hans has answered within this first question. Number two, of course, literally, I will ask you what is database, right? Because we have started defining the term data and what is information, what is database, and what is database management system, right? It's like a ladder before jumping into a new term. We also explain number three, the basic components of database system. We also explain within this chapter. And I will ask you also for to define what is data versus information. You might also answer it in based on how you understood our lesson, or just giving also some more insight in our book, or probably some other references that you might come through, not just by copy pasting it. Differentiate the data from information with the help of examples. Just like I had said, student ID is one of your data. How will going to become an information? They have to process it, they have to register it, and they have to put on your name, right? Student marks, if they have compute all the average of your marks, or total marks, that will come now become an information. So give me also by differentiating the data information with the help of some examples. Number five, there are so many. Definitely you won't be copying all the answers of your answers from your classmate. There are so many. Number six, how does traditional file-based system work? Right? So I have shown you so many examples and diagrams. At least you understand how this traditional file-based system works. And maybe next question I might ask, what are the disadvantages of this traditional file-based system, right? You don't no need to write draw the diagrams. Just write it barely by how you understand our lesson, right? I didn't ask you to define traditional file-based system, but how does traditional file system works, right? Similarly, in 7, it's also connected to number 6. What are the disadvantages of these? Or pretty much maybe why this is disadvantage, why this is a negative side, why this is limited to this one. You might give also some examples, right? And What makes this one that you have given is a disadvantage. There are some points there in our slides. So you can just broad it. Most likely your answer will be the same. Just make it broad. You never know. Midterm will be on campus, right? You'll be writing also short answer questions based on the given questions on your midterm or in finals. So it's better to prepare yourself now by reading and understanding each one of the chapters that we are studying. Number 8, explain about current trends in computing technology. This one is so broad. Right? I might not given you all information in our lesson last Tuesday regarding this slide because it's only one slide and totally it's only talking about what are the latest trends of computing technology. Remember, we have cloud, IoT, right? What makes sense? Why these current trends are have been included here from this chapter? Because all of these current trends are basically use a database. You just explain about this one, and probably by giving some scenario or examples, what makes that technology are how they use a database approach. Number 9 question. How is database management system or DBMS distinguished from a file-based system? This question is comparing the traditional file-based system into the database approach, which is the DBMS. I think any one of you, straightforward, they can answer this one, right? Because you have seen already the file-based system. Definitely there are disadvantages for that. If you know how the process of file-based system, you will going to answer easily this one. Actually, in number 6, one of your answer will be part of that by answering how they are distinguished. Distinguished means they might be having the same process, but the old process, the other process will be disadvantaged or maybe it's limited to that. But when it comes to other one, like distinguish, redundancy, all right. What makes the redundancy from the traditional? It won't reduce, right? There are so many redundancy of working on the file base. Redundancy term also distinguished within the DBMS, but it was reduced. You can just support it why it was reduced and why it wasn't reduced from the file base, right? So that's why the word distinguish, they might be similar, but the other one is better than the other, right? This is distinguish. Just like I asked you, how can I distinguish a two sibling, a twin? But it seems they are pretty much the same face, complexion, color. Totally, they are the same. But how can you distinguish them? Maybe personality, right? Yeah, they are twins, but there are definitely some differences. The word distinguish might be differences. What is their differences between this person to person or other things to things, right? Right. So this is number 9 question. And the last question will be, what are the different DBMS users and their tasks, right? So which is, we have seen the last, pretty much last slide. We have seen the different users of database and what are their tasks. You might be seeing much more detailed tasks or information about those database users because I just make a key point here only. You better see also some more information from your handouts, and it might help you to answer number 10. Okay, this would be at the end of the chapter 1. And officially, we ended up completing chapter 1 by giving you that assessment. I will be providing this assessment questions, 1 second, in our e-learning. And within this, within this, what do you call this one? Within this weekend, you'll be answering this one and upload it from our e-learning. And somewhere by next meeting or next week, we will be having your pretty much your quiz on your chapter 1 alone. Okay, it would be online. I'll be providing you one online quiz by next week, maybe about by Tuesday, only in chapter 1. But officially on next week, we will be also jumping to our chapter 2. Okay, I will provide uh, a home activity only. Activity, I said activity meaning you have to answer those questions. It won't be an assignment, but it would be an activity that you need to answer this. Activity 1. So in chapter 1, and answer all questions given below by just submitting an attachment from this same link, okay? From the same link. So, which means now it would be an open starting by now, and it should be before starting up in Sunday, you should have been submitted this one. This will gonna be recorded. This will gonna be a recorded activity based on your assessment and whatever how many activities we had the whole semester. You should have completed activity 1. Activity chapter 1 will provide a link within the chapter 1 and database and end users. And this time, I'll be now updating now chapter 2 over here. Okay. So don't forget to work on this. And by Tuesday, while we are continue working now with chapter 2, I want you to complete this one. Okay. So any question for this? Please do activity number 1. I already provide the question there in our e-learning and just answered it maybe with the use of Microsoft Word. And no need to write your name because the moment you send your answered attachment, I will record that one. I can see your name there. Okay, so this time I will going to upload now chapter 2, and just for now, let's give at least 2 minutes to 3 minutes of waiting. I'll just upload chapter 2. 1 second. If you have any questions within chapter 1, please do so. Okay, and while I'm preparing also the attendance to check your attendance. Okay, just give me a minute and this will be finished in no time. I will just complete loading now the chapter 2 and let's have some introduction in chapter 2. Okay, by next week, I'll be giving you only about 15 minutes of online quiz 1 for just a matter of 5 marks, but only regarding chapter 1. Okay, not on Sunday. I know it's Sunday is quite difficult, but I have given you an activity assignment work to do so that you will be forced to review and be ready yourself on Tuesday. Okay, so 1 second, let me upload chapter 2 PowerPoint. If you have some questions, don't hesitate to ask. Please do so. Yes, we have just come across completed chapter 1. Chapter 1 is quite very short only because it's more on introduction only, right? And just like I said, most of the practical side of ITDB 101 will definitely start from chapter 2 onwards. And this is most likely the time now to give you an introduction for chapter 2. Okay, so I'm almost about to complete uploading and I'm going to share once again my desktop to you. Okay. I'm just only labeling it and and about to upload it now. Okay, 1 second. Almost finished now. And I do advise to read once again, of course, our reference, which I have attached over our e-learning, so that you can still fully understand what are the importance of chapter 1 for giving an overview, from your database, of course. Okay, now I'm about to upload it now, and I'm good. Wait a minute. Okay, I think I have some questions or message coming to our MS team. 1 second. Let me just attach this one, and I'm good now. Okay, 1 second. Okay, now this time I'm about to open up my desktop once again. Okay, yes, do we have some doubts? Some message came in. How many questions are in the quiz? Are all in questions optional or multiple choice? Okay, it would be a total 5 marks, but the question will be 10 only, 10 questions. And most likely it would be majority or multiple choice. Yes, it would be majority multiple choice. Okay, don't worry. It would be multiple choice question. And make it sure the activity one is definitely it's not a multiple choice. So just try that separately, answer that one and send it back to the e-learning, and that would be recorded in a different assessment. It would be like activity works, of course, right? But in your questions, I'll be giving 10 multiple choice questions only, right? There will be no memorizations there. Just understand very well the chapter 1. And it would be short, definitely. It would be short. Maybe within 15 minutes, you'll be completing. We still have chance to continue our lesson on Tuesday. Okay. Shukran. Sign up. Hopefully, everyone will going to prepare yourself. Anyhow, Sunday is still coming. Okay. Welcome, my dear. Welcome. Okay. This time, I'll just give me some few minutes to give you now on our chapter 2, right? We don't have to spend too much time in chapter 1 because just like I said, the real DBM, database will pretty much will start in chapter 2. Other than those overviews, just barely an introduction still. Okay. Now, chapter 2 now is data modeling. Data modeling using entity relationship model. Entity relationship model. Okay. Or in short, ERM. And things that we are going to tackle here is definitely we will just conceptualize and pretty much we put them in diagrams, something like that. And eventually we will see that your diagram had been now a part of your design. Actually, chapter 2 are now be our first task for us to jumpstart now on working on designing a database. But there are so many things needs to first to take care of knowing how to start with database design. And this is now the first part of knowing data modeling using an entity relationship model. Okay, I hope you grasp this one. Even I'll just give you some partial of a lesson on this, and we'll just continue it on next week, so that we could just have at least some idea now what is a chapter 2. Okay. Our objective from this lesson is after completing this chapter, you as a student should be able to, number one, define key terms such what is entity and what is attribute. That makes sense. ITDB 101, partially it's 30% theory and 70% practical. Practical in the sense that designing, no, just like I said, is even you write it on paper, it's still a practical. those 30% now belongs to this one. There are still some words that you're going to grasp here. Not only we have knew what is information database, DBMS in chapter 1. In every chapter, there might be another new terms that you have to understand. Once that you understand that term, we will going to use that one practically now. Every time we use that term, which means we're talking about on that particular functionality. And entity attributes are one of those. It's an English term, but it's only specifically for database terms. You might hear them in a different English word, but most likely a definition that we are learning somewhere in your ITDB 101. So these words are most likely entity and attributes. Another one, you have heard me using the word relationship. All right, it's quite straightforward. What is your relationship to this fellow? Oh, okay, teacher, he's my brother, or he's my sister, he's my father, he's my cousin. So that's at least an English word now. But this relationship might be in a different aspect because we're talking about database. At least we have already new relationship. But probably this one is quite difficult. Maybe most likely it's your first time to hear it. Cardinality. Okay? We will study that one, and at the end of this chapter, you should now know what is cardinality means. Because that cardinality, again, it will connect to another word, constraint. Okay. So remember, we have touched one word constraint somewhere in our chapter 1, but this time this is about to know what is constraint means. And I believe we have one separate chapter only. We're talking about constraints. Don't you worry. But at least on this chapter alone, you are already knowing some terms: entity, attributes, relationship, and cardinality constraint. Somewhere, somehow, you're not defining specifically their meaning, at least you know their functionality, and you can fully explain by your own language, though, right? How you understood it. But this is how we will going to start. We will know and understand very well what are these terms, because those terms will be included from this chapter 2, particularly in data modeling. And at the end of this, and this is about times the most interesting part of this chapter, you will going to draw an ER diagram. Okay, construct, draw, illustrates, just about showing this diagram as one representation of your design already. But teacher, how can we start working on that one? Of course, we have so many things needs to deal upon with, because this ER diagram or entity relationship diagram will represent based on the scenario. Oh, scenario. Pretty much probation, no? Teacher, advisor, I want to remove from probation. I have 4 courses this time. How much I need to take in my course 1, the other course 2, course 3, course 4, for me to remove from my probation status? The advisor will give you some different options that you may have gone through. But anyhow, it's generic. You need at least a minimum of C for all each courses for you to remove from probation. And you might be having now at least more than 2.0 CGPA. Scenario are based on a problem. Scenario is just you're reading a story. Scenario is just a typical conversation, or you're having an interview between one end user and just talking to him. And what as a kind of professional or colleague of, or you are interviewing this person, you're writing some important details. What are the things that this person told you, right? But of course, our scenario will be pretty much like that also, but there will be some problem on the scenario. And that scenario might become more helpful if someone will going to give you a better solution. And this time, this will come the ER diagram, right? Because you, as the database designer, you are the one who will give them the answer by just showing up your partial, probably, or maybe your full solution, by showing up in a different way, by creating a plan, analyzing it, taking all those information taken from that scenario, and put them already in design perspective. Or in short, you conceptualize it, you model it, you put it in blueprint, and that's it. So which means this is the most interesting part of this chapter 1. We will be having a different scenario, and at the end of each analyzing of each scenario, this is one practical, by the way, already. This would be one of the startup of the practical, because this would be might be included from one of your major exams, that this would be a long answer questions, that we will give you a set of scenarios. Don't worry, we will do that one in our class. We will practice, we will answer some examples in the book, and you will be also having some activity to work upon, and at least you might be ready on this particular part, right? So don't be afraid on this spot. I know it's an English term. It's most likely in a paragraph format, definitely, because scenarios are quite sometimes a bit long, but it depends, no? It depends. And the terms that we are defining every time we starting up a chapter will definitely be used within that scenario. Okay, now that's the time that we come back again to number 1, objective. If you don't understand what is entity, what is attributes, what is relationship, right? What is constraint, what is cardinality, ah, you won't be able to answer the scenario, right? So don't worry, this will be in a slow manner, step by step. And definitely before we will not jump directly with the scenario, don't worry. And we will be having a very stages of this chapter until we come across with that uh, end of chapter by answering now a scenario. Okay, so it's quite interesting. Don't worry, because this is the most likely that students will not be able to forget when you have your ITDB 101. You're creating an ER diagram. You're designing or constructing an ER diagram. Why? Because you will definitely apply this one, dear, once that you are now working with your course project, right? Or probably somewhere in Diploma 2 course project. Your supervisor or your teacher that handles you on your course project, even it's in Diploma 2, Diploma, Advanced Diploma, or particularly if you specialize also in software development, until BTech, you will create this ER diagram. I'm telling you. You will not forget this one, because this is the bread and butter of our ITDB 101. Maybe it will be in a different approach, because I will be practicing you how to give your proper ER diagram based on the scenario. Because at the end of the day, your scenario will be real time now. Because your teacher will ask you to make a proposal, which program or system you're going to develop in your course project, and what makes you decided to choose that program, and why you want to develop that one. What's the benefit of that? And is it beneficial to that company that you are working with? Oh, you're not just sitting down directly from the computer and write the code, develop the program. No, everything will should be in plan. They are all scheduled until such time you might be now ending up of developing the database management system software already, right? It was so long objective. I'm sorry, but I'm pretty excited working on this chapter 2, because this one is basically you will carry this one until you end up of completing your specialization course here in the university. Okay. This time, let's have a fairly introduction when it comes to data modeling. What time is it? It's already, okay, 9:10. Okay. Hopefully you're still there, guys. Okay, I know it's the end of the week. You might be have probably you have finished the first unit. It wasn't fast though. It was only quite short presentation. You can see it um, from our delivery plan. Pretty much is fair enough that we are completing chapter one. Yes. And as a matter of fact, every end of the lesson, I'm giving you and throwing you some review as well. So, right? So I'm just saying that it's more likely only introductory and still an overview, right? You will find this other chapter that you might see, sir, you're so very slow in this chapter because this is the most important part. No issue about that one, right? We're not doing it in the fast mode. We have very good schedules and long duration within this semester, right? And at the end of the day, I will be giving you some assessment. Okay. Now this time, you don't have any questions about chapter 2 introduction objective, by the way. I mean, objective. See, it took me about even more than 10 or 15 minutes. I even only on that slides, right? We're not having a fast mode at the moment here. But if you have a question, why not just throw some questions at the moment, right? Because everything can be read by yourself as a particularly if you could do also a self-study learning as when it's only needed to be read by someone, right? So only some supporting discussion will be there. But the most important is just like I said, this practical side. This practical side will definitely be given so many questions that will covered on this particular chapter. Okay. Any more doubts and questions though? All right. Now let's maybe until introduction, and we might be good, and we'll see some process flow as well, right? So that I could still have a time to mark your attendance. All right. Now this time officially we'll have an introduction. We have already ended of giving a fair explanation what are the objective of this chapter. Number one, in 2.1, we're now first talking about data modeling. Normally, data modeling begins with some research tasks. Just like I said, designing a database is not just you sit on the computer, go on to your codes and design it. Not like that. Data modeling sometimes comes from your mind, and it will definitely it will be like a conceptual. You're just thinking back on your head sometimes. You're already doing some modeling out of your brain, but with the help of some information, I mean data that you need to gather. These are normally typical researcher are doing. They will send some questionnaires to a certain person or group of people, and they might also conduct some interviews for them also to at least to get some information or raw data that needs to be also be processed, something like that. So researching is pretty much it's there, right? So that all your requirements that you might be needing to start off your data modeling will be suitable for you to start off designing your or modeling it from based on the concept that you have undergone. And of course, if you're now also performing data modeling, this is also the stage of you are capturing all the important information. And of course, just like I have said, right? It will not just in one day sitting alone that you can just come across with the design and you're good. Not like that. Sometimes some company, some organization, they have their own requirement. Maybe their program or their system would be slightly different from the other company though, something like that. I mean the way they process their transactions, something like that. So which means you have to tailor it. You have to tailor your uh, your data modeling based on their requirement. Capturing means you're just getting their information, right? Because you need to conceptualize it. Oh, we have to do this one. We should have this one. So many things are there, but sometimes you are also optimizing it, or you're shaping a business that may basically you put that one in diagram or a kind of model that okay, this will gonna be most likely your model, and this will gonna be your revised model because this is the way you do it, and that's why based on your analysis, this would be the best data model for you though, something like that. Because in modeling, there will be a step, particularly on getting your first step is the processing your database design. Yeah, you do processing your database design because this first phase of your step is now we called as a high level design. High level design, just like most of my course project students, I require them to send me your abstract research or abstract of your project. Abstract is like it's like still a concept or you modeled it based on your concept or conceptual design and you describe it and you put that one in modeling phase, something like that. You describe what is the content of this data. You describe what is the relationship between these data items. You describe the rules that might be applied in one of each of your data that will apply specific constraints. So those are the phases of data modeling, right? So which means pretty much it's high level design or it would be an abstract design phase. So once that you put that one in data modeling, at least now you have a reference. You now can go move to the second phase, which we will learn that one later on, right? So all of these things are for you to really understand the data modeling. We have to take all those information, keep a journal with you, and list down all the important things that needs to be put on your data modeling, right? You might be needing to do some research, right? Or the most, at most is the most effective is those people who are wanted to have this one, or those people who are using that system, which they might be needing another latest or another version of the system that will be might be shaping the process flow of their company or their business, right? So it's kind of researching, right? It's kind of researching. But later, of course, data models are pretty much, it will also put it also in blueprint, which means we will be having some diagrams on that one. That's why you see at the end of the chapter, you will going to construct an ER diagram or entity relationship diagram based on the scenario. That's it, right? That's it. Working on data modeling is also, of course, eventually you come up with your ER diagram. In your database development process, these are the different stages or phases of developing. This might be still the same on what's going on these days, that before they develop a system or a new system, they have to do undergone analysis phase. And basically, actually, you have a similar subject for this. I think in your somewhere in your diploma 1 or diploma 2. I don't remember which exactly it will fall this subject. System analysis and design. This is one separate. I forgot the code, but you will be having a separate subject for that. What you're doing is only system analysis. And that is example of one of the database development process. Analysis phase. Analysis phase. Database development process start with the high-level design that what needs to be included there. Again, come back to the data. We collect the data, we analyze the data in such a way that if we process this one, it will become now a better human understanding that makes sense already, and it will be useful, and that will be now information, right? So which means analysis phase. If you study that system analysis and design somewhere in your diploma courses, you will see there will be also a process flow there. Your teacher will taught you how to make a diagram using a system analysis design data flow diagram. See? I will not show it here, the data flow diagram, but that subject will teach you how to work with the system analysis phase. But our phase is on this one, design of data phase, or designing phase, because we are on the database, right? That only then you can do that one if your diagram had been put on place already, such as your entity relationship diagram. But still, you're still a part of analysis phase because this chapter 2 is still under analysis phase. You won't be able to do the design phase if you haven't completed yet the analysis phase after gathering all the data, analyzing the data, and at the end of this chapter, you are still be in analysis phase because you have completed now the data, the entity relationship diagram, which stands for ERD. Okay, see now, you see the stages. You see the stages. Basically, chapter 2 is still a part of analysis phase. Somewhere in chapter 3 and 4, now we might be jumping in design phase. But physically, technically, you will see the design phase in ITDB 202. Right? Because you're going to be working now with some database programs there. The whole semester will be a part of design phase, right? So which means the design phase now is the next phase after getting along with your diagram and organizing them in such your data will be fitted on your ERD. And that next phase will be transformed in more technical model, which is called logical model. Or this is now the relational data model or relational table, right? So which means this will not be possible, this design phase, if we haven't undergone with the first phase, which is analysis phase. At least that scenario that we have seen on our objective will definitely a part of this, right? I might be giving you some projects or small assignments or a part of your practical will be like this, but at least we will understand really how we could put ourselves as a database student, and gathering some information might be a part of a scenario as well. That's why collecting and analyzing the data that a certain business organization needs to track with. So that's already scenario actually, right? Because we need data, we know we need the raw facts and figures first before we come across with that particular ER diagram. Oh, this is the way I also taught my higher level database students, especially if they're now developing a software. We have to sit together and I need to get all the information what they really want to make in a project. And once that they gathered it, that's about time for us to conceptualize by working on analysis phase. And I will going to require them to create the diagram, construct the diagram, or draw the diagram of that particular organization data that they have gathered. And eventually they will show me the ERD. And now I will check. I will check that one. But in your case, as ITDB's one-on-one students, I will be giving you some different scenarios so that it will practice yourself how you put them in ERD. Right, moving on to the building phases. This is basically now the final phase or stage of the development process, though. And definitely, from the word itself, build phase, this is the final, and the logical model are now become much more in a uh, physical application or system or program that they were going to implement. That's why I told you, right? We have different DBMS system like in Oracle, Server SQL, or MS SQL Server, Microsoft SQL Server, or etc. So many. There are so many database softwares over there, right? So these are the three. These are the three processes. If you will see only the diagrams of this one in a typical business information, don't worry, we'll be stopping over here and let me continue this one by next week on Sunday. This is a typical diagram like a business information requirements analysis phase where the entity relationship diagram will going to be developed the moment, but it came from your conceptual data modeling. This is chapter 2. This is data modeling. But the end of this chapter 2, you're still developing analysis phase because I will ask you to work with ERD. And that's ERD stands for Entity Relationship Diagram. Teacher, diagram. Yeah. Are we going to draw? Literally, yes. You will draw a diagram. How will I know, teacher? Because we have some illustrations and we have a list of patterns. What is this rectangular means? What is this diamond or rhombus shape means? What is this circle means? And those arrows connecting one of those or oval shape. And we have some notations on each one of the relationship. We connect them between two entities and like that. We have so many. In this chapter, actually, for you to learn one of those shapes, that's why we are first defining what is entity. Remember our objective, no? We have entities, we have attributes, we have cardinalities, we have relationship. Once that we understand that one, I don't know if you believe me, each one of those terms will become one shape only, one illustration. And I will put them all together. We will put them all together in such a way where every time you see that image or shape, you know that is already that particular function, which we have understand what is this entity means and so on. Right. That's why it's a stages by stages. I will not just jump there on the list of shapes or different diagrams and we draw them and put them all together just to say that now we are developing entity relationship diagram. Right. So it still be quite shallow for us because we're not seeing yet at the moment that conceptual data modeling. Until such time, maybe inshallah by next week, right? We might be running 1.5 weeks to might be completing this chapter 2. It depends. It depends, right? So much for that one. You can see the second stage there or phase was the design. And basically, this would be particularly another chapter, right? And this designing phase is basically we're now starting up designing the database. Yeah, you are doing design also in the first phase, but literally you're just gathering information. That's why you're just only analyzing it. Just like I said, you have a portion of your subject which is system analysis design. It would be a part of it. It would be a part of it, right? But when it comes to this second phase, you see this design phase. These are basically now can be done some other transformation. Like you define now your entities on the analyzed phase in like a physical kind of table, right? So now you know that you have this table, you have this table, you have this field, you have this constraint, you have this relationship, and you have this data as well. And everything does, we might be giving some definition of all of these. That will later on, you're going to really build now your database design, which you have done it on the second phase. That's why you can see the arrow. The cylindrical shape is the most popular shape that which means you're connecting to a database or you're creating a database. Right. So it's quite common symbol. So throughout the learning stage of database, it's quite common they use a cylindrical shape. So which means assuming that we knew that we are now working on a database, right? So I think so much for that one. And I might be continuing this lesson by next week. And once again, just a reminder, how many quizzes have we finished the first unit? Any, how many, any questions? Yes, we do. We already completed first. I think I answered this one already, right? Yes. Just for a record, don't forget to answer your activity number 1 in your e-learning. It would be fine here in chapter 1. There will be a link there, activity 1, chapter 1. All you have to do is to answer those 10 questions. And you may write it, if you want, you can write it in paper, take a snap, and attach it over here as you like. Or probably not if you want to write it in Microsoft Word and send back to the link, it's okay, fine for me. So this will going to be a recorded a part of your activity in your courseworks, of course. And just for heads up, on Tuesday, I'll be giving you an online quiz 1, which only 5 marks, having multiple choice questions of 10 sets only. Okay, that would be only dealing with chapter 1. Okay, and that's it for now. And let me just allow me to mark your attendance, and pretty much we're good. And if you don't have any question yet, just stay put there and let me allow me to mark your attendance. Let me just okay. Anyhow, I'll just directly uh, record it though. It's better, and let me just download it. Uh, your attendance data a bit for my reference. And please be monitored with your attendances because I don't want you to occur so many warning letters or warning. And see, I'm getting some warning. I mean, a percentage of absences already here. Now you will come across to this one and limit your absences even though you are online or offline on campus classes. Okay? Okay, so please help me to identify your name in case I might miss your name though. Okay, Abdul Salam Abdullah Ahmed Rafid. Okay, present. Okay. Uh, oops, why it's coming? Okay. What about Abdullah Masood Ahmed Suhail Al Mashini? Okay, present as well.
Yes. Yes, Abdullah.
Yes. Yep. What about Abdullah Turki Abdullah? Okay, I'm present
Yes,
also.
Master.
Thank you, thank you. I can see you.
Teacher, you is
Mm.
finished.
Yeah, yeah, yeah. You can go. After
Okay.
I did this one, you can
Thank you,
go.
teacher.
Welcome, dear. This will be finished in no time. Al Harit Ghanem Al Shanfari, I believe it's not here at the moment. I'll just mark him absent at the moment. Al Hussein Ahmed, yes,
Yes,
present. Yes, thank you, Al Hussein. Good to hear your voice. Al Mahad Nahar, Anasar Abdullah Al Khalid, Al Mahad. Al Mahad, I think he's not around. I'll just mark it absent. Oh, no, 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 I'm sorry. Al Mahad, Ammar. No, 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 no. Al Hussein Ahmed. Wait. Yes, Al Hussein. It's not around. Al Hilali. Okay, Almanad Nasser Abdullah Khalid. Al Khaldi. It's also not around. Okay, seventh one is Amer Salim Abdullah Shanfari. Amer. Okay, not around as well. Salah Adil Omar Bait Salim. Okay, there's no Salah here. Basel Ahmed. Okay, Basel, you're there. Good. Present. Basel. Bashar. Bashar Amr. Bashar is also not around. Hadil. Hadil Khalid. It's pretty much not around also. So I'm getting so many absence at the moment. Jamila. Jamila. Okay. Jamila is also not around. Masin. Masin Isa Awad. Okay. Masin is there. Yep. Muhammad Nasser. Muhammad Nasser. Okay. Muhammad Nasser. Okay. It's not also there. Muhammad Saeed. Muhammad Al Shanfri. Okay. Also absent at the moment. Mona. Mona is not around also. Mariam Said. I'll just save this one for a while in case some of you came to message me in our MS team. Mariam. Mariam Said, yes, she's there. Osama Akil. Osama Akil, yes, present also. Ryan Hamid, okay, present also. What about Safia? Safia is not around. Okay, Safia is not around. What about Toful Badr? I think I have some. Yes, she's there. Yeah, first class I saw them, and Toful Said. All right, present also. And last two, Wafa and Sainab Mubarak are present. Oh wait, why I mark absent for the both Tuful? Okay, present. All right. Yes, you're present. Tuful Badar, Tuful Said, Wafa, and Sainab are present. So, have a nice day and have a nice weekend ahead. Thank you very much for coming in, and inshallah, we'll see you next week. Okay? So, you can leave now the channel, and this is a recorded session. I will be stopping the recording and share this one in